Welcome back, guys. We're going to look at 3-3 today, which is our third type of rigid motion, right, is rotations. And so we have actually only one objective. We're going to cross this objective off today because we're not going to look at it. So the only objective that we have for the day is to rotate a figure and then to write the rule for rotation. So just like we learned how to write a rule for reflection and we learned how to write a rule for translation, we're going to learn how to write the rule for rotations. And so rotation is actually our only new vocabulary today. So we're going to go to the end of the packet and fill out our one vocabulary term, and then we'll come back here. All right, so here on our terms list, we have rotation. And so a rotation is a type of rigid motion. So again, rigid motion means that the size and the shape do not change. Okay, so it changes maybe the way it looks, but the size and the shape don't change. Where all points of the shape are rotated around a fixed point. So if I have a shape, I'll do my best on drawing this. Okay, let's say that I have a square, and let's label it A, B, C, and D. If I have a fixed point, let's say that this fixed point is P, and I rotate this figure around point P, and I'm going to still have a square, right? But it's going to be rotated, right? This would be D prime now, and this would be A prime, and B prime, and C prime. Okay, so all we're doing is we're taking a shape and we're rotating it 90 degrees, 180 degrees, 270 degrees, right? 360, there's lots of options. And so when we rotate, we use a lowercase r. The uppercase r was reflection. So we use lowercase r, okay? And two things here. One, this will tell you the degrees of rotation. So are you rotating 90 degrees? Are you rotating 180 degrees? Are you rotating 30 degrees, right? And then this will tell you the point of rotation, right? Like what point are you rotating around? In this example, we are rotating around point P, okay, but it might be something different. We just know, so a lowercase r is rotation, an uppercase or capital R is reflection. So that can just get kind of confusing. So we just want to make sure that we're being really careful there. Okay, so let's go back to our notes. This is the only definition we have for today. Let's go back to our notes and look at the concept of rotation, look at the rules for rotation, and see if we can get some examples done. Okay, so back to 3-3 in our packet. We have this concept that we want to talk about here, and the concept is rotation. Okay, so a rotation, notice here's our notation. Lowercase r, the first number is the degrees, right? Angle measure of x degrees. And then the P is the point that you are rotating around. Okay, so the image of P is P prime. All that means is that whatever your point of rotation is, it just stays the same. Your point of rotation does not move. Okay, so if I'm rotating around point P here, then P prime would also be the same thing. And then you're rotating, and how you're rotating is x degrees. So I'm rotating from P to P prime x degrees. Quick note is that a rotation is a rigid motion, so the angles and the length of the sides do not change. This is really important right here. A rotation is counterclockwise for positive angle measures. That is so important. So if I tell you to rotate 90 degrees, it means 90 degrees counterclockwise, right? The opposite way that a clock hand moves. If I ask you to rotate negative 90 degrees, now you're going to be going 90 degrees clockwise. So positive angle measure is counterclockwise, and that's super, super important. So let's look at what this means for us. And I gave you the rules here, which is kind of nice. Notice that the degrees here are all positive. So that means I'm going to be rotating counterclockwise. So if I'm rotating an image or a pre-image, a point in this case, 90 degrees, and this is an O. It looks like a 0. It's an O. It stands for origin, right? So I'm rotating 90 degrees around the origin, which is the 0, 0 point. So if I have this point, all I do is I switch the X and Y, right? Now my Y is first, my X is second. So in this case, my Y is first, which is 2. My X is second, which is 1. And my Y term multiplies by -1. So then I have a point at -2, 1. Right there, -2, 1. And that is the point A prime, because I have rotated it. And that is the rule if you're rotating at 90 degrees. Okay? If I'm rotating it at 180, notice that the X and the Y stay in the same position. They just become negative. So in this case, I'll have -1, -2. So -1, -2. So this would be A prime if I was asked to rotate 180 degrees around the origin. And then 270, so this is 3/4 of the way around, so 3 90-degree turns, right? Again, I switch the X and Y, so that's 2 and 1. But now the X multiplies by -1, so now I have 2, -1. So this would be my A prime. So these are just rules that we can follow, okay? But there's a couple stipulations here that I want to write down. Okay, so these rules only work for rotations around the origin. And again, the origin is that point 0, 0. So if I ask you to rotate around this point, these rules don't apply. You cannot use them. Okay, you can only use the rules if you are rotating around the origin, which in this case, all 3 of these were, right? Because that second term there in the parentheses is an O for origin. And then I want to write this again just to make it super clear. For positive degrees, we rotate counterclockwise. So important. Oops. Counterclockwise. Okay, I'm going to underline it like 50,000 times. Okay, if I have a positive degree, I'm rotating counterclockwise. Okay, so what we're going to do is we're going to look at 4 examples here, and then we're going to be done. So it's pretty quick. And we're going to keep these rules in mind. And if you need to go and look at your notes and like go back and forth on the pages when we're doing this, totally fine. Okay. So here, we're going to practice. It says, what is the rotation of 90 degrees around the origin of ABCD? So here's ABCD. So I'm rotating around the origin. And I'm rotating 90 degrees. So if you go back and you look in your notes, 90 degrees means for my points, right? I switch the X and Y, and the Y multiplies by -1. So that's my rule. So what I mean by that is A is at the point 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. So without even having to graph it, I can tell you that A prime is at the point negative 5, 3. I've switched the x and y, and then the first term gets multiplied by negative 1. So negative 5, 3. And this is the point A prime. Okay, for B, my original B point is at 1, 7. So if I use this rule, that tells me that B prime is going to be at negative 7, 1. So 5, 6, 7, 1. And that's going to be my B prime. My original point C is at negative 2, 4, which means C prime is going to be negative 4, negative 2. So negative 4, negative 2, so C prime. And then my original point for D was 2, negative 1. And so D prime, when I multiply negative 1 by negative 1, I get positive. So that's going to be 1, comma 2. So 1, 2 is going to be D prime. Oh boy. And then from there, I just connect the sides. Hopefully you did better than I did. And then there's my figure. There's my rotated figure. Okay, so let's look here. What do we have? We have 3 try-its. I want you guys to give it a shot. They tell you what your original point is, so you're gonna have to graph. I guess you don't have to, but if you want to, you can graph the 3 original points and then rotate it 180 degrees around the origin. Then you're going to rotate it 270 degrees around the origin. And then C has its own graph. So go ahead, give these a try, and then let me know, or when you're ready, just hit play on the video and I'll go over it. Okay, so let's look at the first one here. I've graphed the original triangle XYZ. So there it is. And I want to rotate this, 180 degrees around the origin. Okay, well, 180 degrees, if we go back and we look at the rule, I have a point XY. The order stays the same. We just multiply them both by negative 1. Okay, so here, x prime, right, is going to be negative 4 times negative 1, which is 4, and 7 times negative 1, which is negative 7. So positive 4 down 7, 4, 5, 6, 7. And that's going to be my x prime. For y prime, it's going to be the same thing. 0 times negative 1 is still 0. 8 times negative 1 is negative 8. So this is going to be down here. 8. So this is going to be y prime. And then z prime, 2 times negative 1 is negative 2. Negative 1 times negative 1 is positive 1. So I have 2, 1. And I can connect. And there's my rotated triangle. Okay, so hopefully it's not too bad. If you have not done part B yet, pause the video and do it. Otherwise, if you have done it and you're ready to check your work, we're going to go over it. Okay, so let's go ahead and look at B again. Here's my original triangle that I drew. And if I look on the other side of our notes, I can see that the rule for 270 degrees is that I take my point XY, I switch the order, but now my x, is multiplied by negative 1. So we should be able to graph this then pretty quickly. So I switch the order, so 7 comes first, and then negative 4 times negative 1 is positive 4. So 7, 4, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Here's x prime. For y prime, right, 0, 8, I switch the order. So 8 goes first, and then 0 times negative 1 is still just 0. So I have 8, 0, just here. So this is my y prime. And then z, I switch prime, z prime. So negative 1 comes first, and then 2 times negative 1 is negative 2. So I have negative 1, negative 2 is my z. And I connect them. Hopefully your work felt good on that. Just knowing the rules is really what it comes down to, and looking back on your notes and making sure that we know the rules, okay? Our last example is, what are the coordinates of a rotation of 90 degrees around the origin, of B? So here's B. So B is the point 1, 3. And our 90-degree rotation around the origin tells me that I switch the order and I multiply my y by negative 1. So negative 3, then 1. It becomes my new 1, 2, 3, 1. And so here's my b prime. I got negative 3, 1. And that's it for rotation. We just basically, making sure that we are knowing those rules on 90 degrees, 180, 270, such, and like that. And then that's kind of it. So if you have any questions on rotations, make sure you reach out. Otherwise, we're done. See you later.